All right, so we looked at this code the other day and people couldn't read it. So I confess, I spent an entire day redoing the slides, and I redid them where we looked at them. You can look at those and maybe we'll review them someday. And I did them a little quicker here. So this is the code for printing neatly. All right. So let's say, and all the code is going to have the same basic structure. You loop through the sub-instances, you loop through the bird answers. Let's just have a review, since it's been a while, of the printing neatly problem. All right. Let's see if, there. So remember, your text is your input is this text. Say maybe be sure to be honest and kind, and you have the width of your page, right? And the goal is to print it, to decide how many words to put on each line, in order to minimize on each line, you count the number of spaces. On the end, you cube that and add it up, right? And the way we did it last class, which is new for this term, is we converted it, we reduced it to shortest path. So the nodes were, if you were walking through the game of life, you would start at S and you say, oh, my next word is B, and I'm starting a new line. So then I'm going to ask the bird how many words to put on, on the first line. She would say 5, and I would jump over 5 words, right? And the weight of that edge, I know those 5 words, so I know how they fit on the line. I know how many spaces are in the end of those 5 words. I square cube that, right? That's the weight of that edge. And now I'm ready for the 6th word, right? Everybody remember that game? And so that was this graph, and so our instance is the best way to print all the words, which is related to the best path from S to T. And we can ask, well, what are our sub-instances, right? So for each node in this graph, there's going to be a sub-instance. I'm indexing the words by I. Generally, I index sub-instances by I and J, and I index bird questions by K. Why? If you do it all the same, then you remember, it helps you, right? And if you do it the same, then you'll be doing the same as me, and the TA would be happier, right? All right, so we can, from here, we can talk about the past problem and the future problem. What's the future problem is what's the best path from where I am, VI to T, right? That's a future problem. And that, of course, relates to how do I best print the last n minus I words, right? How do I, they're going to be on lines by themselves. How do I print them, right? And that's a separate question from the past question, which is what's the best path from S to VI, and how do I print those first I words, right? Does that make sense? There's 2 problems there, and we're either going to solve the, we're either going to start this way and solve the past problems, or we're going to start here backwards and solve the future problems. And it doesn't matter, but aesthetically, it feels more natural to go forward, right? So that's what we're going to do, is that's going to be our sub-instance, is how to print the first I words, right? Does that make sense? And that just says aesthetically more pleasing, right? I mean, that's it. but it's all symmetric, right? So whatever. All right, so now we're going to go through, as I said, I took piece. The only problem with this is we don't have the code in its entirety. You're going to see pieces of it, but we're going to go through pieces of it in order, but at least you should be able to read it. I mean, people can read that now, right? Good. All right, so, right, be clear about what your instance is. All right, so an instance tells me the lengths. I have n words. Each a particular word has I don't want to say I. Oh, sure, let's say I. The ith word will have li letters in it, right? Because all we care about is how many letters are in it, because all our letters are the fixed width. And then, and the n is the width of the text, right? That's the input. What is our solution? Our solution splits the text into lines in the optimal way, right? And that's what we return, and we return the cost of that solution, right? So, all right, so the first thing you're going to do as the programmer, or actually in the computation, is to set up memory to store all your solutions, right? So the key is ahead of time who all your solutions are going to be, all right? And so who are our solutions? Well, they're going to be indexed by I, and here I'm giving it a name, sub instance I, bracket I. And now that, of course, that's just the name, so we can talk about it. It's not actually stored anywhere, right? And what is it? It's basically, how do I print the first I word, right? Because that's what we said, right? And and then we're going to set up a table. Here's a table that's indexed by them, right? So here it looks like I'm storing the sub instance, but we don't actually store that. I'm just listing them to you for good luck, right? And you can see 11 words on the line and how many letters are in each word, right? And of course, sub instance 8, if you count, has 8 words. All right, so here, what's our solution? Here, optimal solution I would store the optimal solution, how many words to put in each line, but that takes up too much space, so we're not going to store it, right? What are we going to store instead? We're going to store the cost of the optimal solution and the bird's advice. All right, everybody get that? Everybody get the picture here? All right, so when I was teaching it before, I first taught recursive backtracking as a recursive algorithm, and that muddled people. So then on the exam, we would have a base case like if it was recursion, right? If it was recursion, I would say, if my input is the base case, then I will solve the base case, right? But that's not what we're doing here. It's not recursion, right? We are solving all of the sub-instances. So no matter what your instance is, don't have an if statement. No matter what your instance is, you solve the base case, right? So what is the base case, right? It's when we have no words, 0 words. Here it is. How do you print the best 0 words? Well, it's going to have 0 lines, 0 costs, 0. I don't know. The bird's advice is whatever you want. We're done, right? All right. So then, what we're going to do is, as I said, your job is to finish all of these sub-instances, and so we loop over them, right? Here we iterate over the remaining sub-instances. So we did 0 already, so we're going to do 1 through n, and there we did them. Don't you love animations? What order do we solve them in? We solve them from smallest to largest. And what I always say is we solve them in an order so that nobody waits, because if we were doing recursion, I would need help from my friends. And if my friends hadn't done their job, I would have to wait for them, right? But because my friends are smaller, if we do them from smallest to largest, they're done already, right? So there we are, we're looping through them. And then, right, what is our goal is to solve this one. And so you'll note there's a big blue in the middle where is where we actually do this. But at the bottom of the loop, we commented out storing the solution, but we store the cost in the bird device. Right, everybody? That was just so that you can see what this loop is doing. All right, so now I filled here. That didn't change, right? What we did is we filled in the rest of how to do it. All right, so now what we do is I like to say, don't try to solve everything, right? Focus on your job, and your job is to solve the ith instance, right? So this is just saying, go, do a little meditation and embody, channel's the word. Channel the need to solve this subinstance, right? So your job is to deal with these first I words. All right, and how do you do it? Is you do it by what I call the friends and bird algorithm, right? You're going to have ideally you're going to have a bird, but you don't have a bird, so we try all the birds. And so what we're doing here is we're looping through all bird answers, right? And what is K here? K was some weird calculation, so I didn't do it. I just did it in English. K is kind of the maximum number of lines. It's kind of starting from where we are to how many of them will fit on my line, right? All right, so that's K. I'm indexing them. Be clear which one you're trying. So again, I'm going to say, let's channel that I'm Mr. I, and the bird's channeling that a particular K, right? So, so I know I'm trying to print I words. What do I ask the bird? How many words to put on the last line? She tells me some K, and then my goal is to compute this thing. And let's just be clear what this thing is. It has an I, it has a K. Why is that? Because it's the best way to solve, I'm Mr. I trying to solve the I subinstance. I'm trying to get the best way to print I words, right? Consistent with the kth bird answer, right? So this notation here, if you're trying to write code like this, which probably you will be, you might want to just, quite frankly, might want to copy this from me, right? Copy it from me. Why? Because the only thing you might have to change is maybe I have a two-dimensional set of, I have a matrix of subinstances, in which case this is an indexing over I and J. And then I've never heard of a two-dimensional device from birds. So that'll be a K. And then you'll have an IJK here, right? It'll be the best solution to your problem, IJ, consistent with the bird answer K, right? That's what we're trying to find now. All right. So, and this is just saying that's a comment. We're not saving it, but I say leave those lines, put that line in there so that the marker knows that you know how to do it and knows that you're not doing it, right? In fact, it's somewhat easier to do this. And then once you've done that, think, oh, now what's the cost of that solution, right? So it's kind of in the same boat here. All right. Now, as I said, we're channeling, I'm Mr. I and I have Mr. K bird. So now we're doing the friend-bird algorithm. And traditionally, the last 20 years, I've asked students to give me, I start by give me the bird-friend algorithm, right? The only reason we might not, we're now focusing less on the bird-friend algorithm and more on the game of life. So I don't know how that'll work out in the test. But what is the bird-friend algorithm, right? So I'm saying here, put it in as a comment unless you've answered it earlier, so you don't put it twice. I'll tell you, we'll figure out together whether we're going to do that. All right, but what would it be? What do you ask the bird? All right, you ask the bird, hey bird, you say bird, I have to put I words. How many words do you put on the last line, right? And why is it the last line and not the first line? Anybody know? Because our sub-instances are printing the first I words. And so we want to make that sub-instance backwards from the forward, right? So that we have our friend is smaller this way, not smaller this way, right? Friends. So we asked the bird about the last I words, and then my bird says K. So now I know that I minus K, the first I minus K words are on lines by themselves. And I have to figure out how to print those. And I don't do it myself. I get my friends to do it without micromanaging it, right? My friend tells me how to print the I minus K words, right? And how do we get his solution? Well, it's just table lookup, right? One thing you're missing here. Sorry, if we had the whole page, I would have circled at the top, review what the sub-instances are. And it says sub-instance I is printing the first I words. So what do we need? What's your friend doing? He's printing the first I minus K words. So there he is. Oops, that was weird. He's there. His optimal solution is in the table indexed by I minus K, right? Here we're going, I'm printing 8, we backed it up to 5. Remember that? Oh, and here's Pooh Bear. He needs to print all the way to the end. He's Mr. 8, and his bird told him to back up 3 words, right? Everybody see that? And either way, that's our friend, is that I minus K. All right. Because this instance is smaller, we assume by our loop invariant that it's already solved, and we can just look it up in the table. And now, how do you take our friend's solution and our bird's advice and combine them? All right. So what we do is we add the bird's K words as a new line on the end of what our friend gave us. And that takes here, our friend printed I minus K words, our bird printed K words, and that gives us a printing of I words, right? And here you can see it down here. Our friend in purple is printing I minus K words. That's going to tell, what is he telling us? He's telling us how many words to put on each line, right? That's the solution. And then we're saying from our bird, and then there's another line with K words. Right? Everybody see that? This is just a concatenation of how many words are in each line is our solution, right? And then what is our cost? Well, we took the cost of our birds, of our friend's answer. Our friend told him his cost. And then what we do is we took our last line. Here we are, I don't know, this doesn't even look right to me. That superscript should be a K, shouldn't it? Anyway, we're summing up. I think the superscript should be a K. And no, sorry. Our words that go from basically I minus K to I. Those are the lengths of the words, right? Sorry, that is right. We sum up the lengths of the words. We have an extra 1 per word with the space in between. Then there's plus and minus ones that we have to deal with. And then this is the length of the whole thing. So how many spaces left, and we cube it, right? Everybody buy that? All right. that was our best solution. I think I said that already, and we're done. Everybody buy that? All right. Yeah, I mean, it's short, right? It's the actual code is short. All right, so now we after that. Here, see, this ... is looping over all bird answers, right? So I'm still Mr. I. I'm still trying to solve the I problems, but I have, what do I have? I have the best answer for each bird answer, right? And right, so for each bird answer, I have the best answer consistent with it. And all I do is I take the best of the best, right? So here, this says, give me the K that minimizes this value, right? And one thing is a hint that you might need to change on your test is if you're doing a maximization problem, right? Then you change min to max, right? All right, now I know which bird answer I'm going for. So what's the cost? Is the cost that's associated with that bird answer, right? And I store the bird answer, which is K. Right, everybody buy that? Okay, and then we're, then this is the end of the loop. That N4 is the end of the loop overall bird answer, overall sub-instances. So now we've solved all sub-instances, and particularly we've solved the last sub-instance, right? Why is it that what you're looking for is in the last place you look? Because when you find it, you stop looking, right? It's a good joke, right? It's a dad joke. I'm a dad. All right, so we found them all, and right. So what is the cost of the minimal solution? Oh, you can see here. This is cut and pasted, I guess, from doing min path. But that's okay. The cost is there, right? But here the optimal solution. We don't have the optimal solution because we didn't compute it as we went along the way, right? So what I have people on the test do is they just say they're doing it again, but this time they have the bird's advice, right? And the algorithm is you either could do it recursively again with that help, or you could do it iteratively, right? It's pretty easy. I don't make you code it up, right? So that's just what we're saying here. Here we follow the bird's advice backwards, right? Because my bird tells me my last edge, right? So I follow it, right? My bird tells me the last number of words on the last line. So I go backwards, and then his bird tells him the next line, right? And you follow it back. Right, so I think here we're just following it back again. All right, everybody good with that? There's the code if you want to see it, if you want to not read it in its entirety, right? Time. So there's a big loop over the number of sub-instances. So clearly the time is proportional to the number of sub-instances. There's a big loop over the number of, oh, that's in the wrong spot. Move that down slightly. It should be down here. I guess I cut it and pasted it from other code and we shifted things, right? All right, so that's the number of bird answers here. Now, here's the funny thing is this line of code takes order one time, right? But this line of code takes order in time, right? And that's why we're deleting it. And so that's our runtime. Number of sub-instances times the number of bird answers, which also is equal to the number of edges in the graph, right? Number of sub-instances equals the number of nodes in the graph. And by number of bird answers per sub-instance, I mean the degree of each node, right? So the number of nodes times the degree of the node, which is the number of edges. Good.